So many adults talk about their fear of maths and their fear of numbers, and it's almost acceptable to say that. And I think what happens for so many people is in their childhood, maths and numbers were frightening. So I just think one of our biggest jobs is to make numbers fun. Numbers are something you play with, numbers are something you're better than, numbers are something you can beat. And if you can get that attitude as young as possible, children then just have a long-standing confidence with numbers.
Today we're going to be revising what is meant by a factor, and we're going to learn a fun way of remembering and working out factors. Factor bugs are a great visual way of getting children to understand and work out factors. So who can start us off and remind me, what on earth is a factor? What do we mean when we talk about factors? Ben?
Factors are where numbers fit into another number.
Fantastic! Factors are numbers that divide exactly into another number. So who can give me a factor of 20?
10.
Fantastic. Who can give me a factor of 36, a number that fits into 36? Mia?
18.
Good girl, absolutely, 18. Factor bugs are a way of working out the factors of a number and seeing it visually, so it helps us to remember them. So we're going to start with the number 12. What are the really cheeky answers for the factors of 12? Hannah?
1.
1. Why is 1 a really cheeky number, Hannah?
Because it goes into everything.
Fantastic. 1 is a factor of every number. What other really cheeky answer is there?
12.
And why is that a cheeky number, Cheryl?
Because 12 fits into 12.
Absolutely, good girl. So we're going to transform this into a factor bug. So we need a little head and we need a body. And we're going to make those cheeky answers the antennae, 1 and 12. And that's the same for all factor bugs. So now we need to give this factor bug some legs so that it can move. So we're going to think of the other factors that fit into 12. So we're going to start from the lowest numbers. So after 1, what's the next number that fits into 12 perfectly? Lily?
2.
2, absolutely. So we're going to put 2 here. 2 fits into 12. How many times?
6 times.
6 times, absolutely. 2 times 6 is 12. So watch carefully. The 6 is the other leg. We think about factors in pairs, don't we? Who can help me with the next pair of legs? The next pair of legs. Amaral?
3.
3. And how many times does 3 fit into 12?
4.
4 times, so that's the other leg. If you have a square number, the children quickly realise that it doesn't look quite right to have the same number on either side of the bug. So we've come up with a great idea of putting a tail on the factor bug for a square number. What kind of a number is 36? If 6 times 6 makes 36, what kind of a number is it? Joe?
It's a square number.
It's a square number, absolutely brilliant. So what could we do if we've got a square number? We've got a really good trick. We're going to put a little tail at the bottom and write a 6. So when children are doing square numbers in other areas of their maths learning, they often refer back to, oh, that factor bug had a tail, so I know it's a square number. When the children are working independently or with their talking partner on the carpet with their whiteboards and pens, they'll make some really interesting discoveries. For example, children often quickly spot that all the prime numbers only have antennae and don't have any legs. And this again is a really good way of them spotting that prime numbers only have 2 factors, 1 and itself.
Could that be 64?
An additional activity you can do with factor bugs, which really pushes the children's learning on and encourages their thinking around this idea, is playing Spot the Factor Bug or Guess the Factor Bug, in which we put up a range of different factor bugs with no numbers written on the tail, on the legs, on the antennae or on the belly, and children have to guess what the number could be just from looking at the factor bug. And let's do this one, which is a very odd looking factor bug. What is this factor bug? There is only one possible answer this factor bug could be. I can see lots of you have worked it out.
It has to be 1.
Fantastic. Why does it have to be 1?
1 is the lowest number it can be, so it fits into everything there.
Fantastic. So you'll always recognise this factor bug. You'll always know that that's 1. By giving something a silly name like factor bugs, we've made a really important area of maths accessible and fun for everybody.
You can choose any times table you like, okay? And I'm going to do the 3s. And I want you to write out your multiples of 3. Do you want to chart them for me to help me? 3, 6, 9. Last digit patterns is a great activity because it's got a good combination of all sorts of things that work in a lesson. It's actually quite structured. The first thing that I do is model one of the times tables on the board for the children and also model how to go about the task. And I always choose the 3 times table because there's no immediate pattern. I want you to get a coloured pencil and I want you to underline the last digit, the units digit. That's easy because there's only 1 digit there. So I write them up on the board, go through the kind of quite controlling bit about underlining the last digit and then begin to model how to join up the digits on the circle. And then you're going to take a ruler and a pencil and you're going to do this. I'm not going to use a ruler, but you're going to use a ruler. You start on the first digit you've underlined and you join it to the second. So I'm going to join 3 to 6. So from 3 I'm going to go to 6. And from 6 I'm going to go to 9. And from 9 I'm going to go to 2. And from 2 I'm going to go to 5. And from 5 I'm going to go to 8. From 8 I'm going to go to 1. From 1 I'm going to go to 4. From 4 I'm going to go to 7. From 7 I'm going to go to 0. And from 0 I'm going to go back to 3. And I have to say, even with my rubbish drawing, what have we got?
A star.
It is. We're going to go off and you're all going to choose your own times table. You're going to write it out. You're going to underline the last digit and you're going to see if you get the same star as me. But before you do that, I can think of 2 times tables that might be very boring. Can anybody think which ones are going to be pretty darn boring? Stanley?
10.
The 10s. Show me with your finger what your pen's going to do. Exactly. You're going to be joining 0 to 0 to 0. And I'm going to come up to you and say, you haven't done any work. Get on with it. You have. You've been sitting there for hours doing that. The other really critical question to ask before they go is, does anybody want to predict which times tables might make this same star, like the 3 times table? Who can be mathematical and predict which pattern might be the same as the 3s?
The 6s.
Good thinking. Why have you gone for the 6s?
Because 6 is double 3.
OK. Almost always a child will suggest that the 6 times table will make the same pattern, which is great mathematical thinking. And you ask them why, and hopefully they will say because it's double. Somebody else will then propose the 9 times table. And this is the point you want to leave it, with them all expecting that, because that isn't what happens.
Up with a pentagon and that's got 5 sides. 4 is a star and so is the 6s.
So our prediction was that the 6 times table will be the same as the 3 times table. Were we right? No. It is vital that the children come back on the carpet at the end. It can't be a lesson where they just go straight out to play, because the wonderful twist of the lesson is that for some reason that escapes me, the 3 times table makes the same pattern as the 7 times table. The 6 times table makes the same pattern as the 4s. The 8s pairs with the 2s, the 1s with the 9s. And the glorious moment when the children see that, make the connection, and it all begins to unfold is just fantastic. So the 6 and the 4 times table make the same pattern and add up to 10. And 3 and 7 add up to 10. So did anyone like to guess another pair of times tables that might have the same last digit pattern? There's some connection somehow which links number bonds with last digit times tables patterns, and in that sense it makes a great maths lesson. We've discovered that there are patterns, and it's more magic maths because the patterns are the same are times tables that add up to make 10. It's more magic maths.
Right, Year 5, we're going to start off our lesson and warm our brains up with our counting stick, and we're going to count through our times table. What's our times table of the week? Thomas?
9 times table.
Good boy. So we're going to look for the 9 times table in our little bag. Could this be the 9 times table?
No.
Could this be the 9 times table? Yes. Why could it be the 9 times table? Hannah?
Because 2 9s are 18.
Good girl, well done. Could it still be the 9 times table? Yes. Excellent, you're absolutely right. It is the 9 times table. So I need some help putting the cards on our counting sticks. Counting sticks is a great maths idea because it's a fantastic warm-up for any lesson. It gets every single child involved regardless of their ability. Everybody feels a part of the lesson. If we're going to start at the beginning with 1 times 9 is 9, who could come and tell me where 27 is going to go? David, come up and show everybody on the counting stick where 27 is going to go. Excellent. Good boy. Thumbs up if you agree with David. Fantastic. Well done, David. Brilliant. Who can come and show me then where we think 72 is going to go? Have a moment to think and count through. Where's 72 going to go? Malachi, come and show me. How many times does 9 fit into 72? What times 9 makes 72?
8.
Good boy. So where are you going to put it? Let's count on. Good boy. 36. It's a fun way of getting everybody involved
99.
and learning their times tables. We're filling up our number line. So what do we call all these numbers? We've got our 9 times table up on the counting stick. What name do we give to all of these numbers? Manashi?
Multiples of 9.
Fantastic. And what do multiples mean, Manashi?
It means a number that, like 9 times itself or times by another number will make one of those numbers.
Absolutely, well done. Once they're all on the stick, we then chant the times table as a class.
1 9 is 9. 2 9s are 18.
And once they've got a really good grip on that times table of the week, you can start using and applying all those facts that they've learnt, and this helps children realise that if they know a certain fact about the 9 times table, they should be able to answer much harder questions, such as 90 times 3, because they look for the easy question and then they add on the zeros. So if you know that 9 times 3 is 27, you should be able to tell me what 90 times 3 is. Who can tell me what 90 times 3 is? Sophia.
Is it 270?
Good girl. What's the rule that we do? David.
We add 0 to the number.
Sometimes the simplest ideas are the best. And the counting stick is such a fun way to get everybody in the class learning their times tables, getting involved in maths and having a really good time.